Alright, y'all. We're going to go through some of these questions here on Unit 3, Worksheet 2 to kind of get you going. I'm going to do one of these problems and a couple of those graphs below to help you out. So what we're doing here on number 2 is we're just finding all the information that we need to actually do a graph without graphing. But what we look at is degree and leading coefficient. That's what we started out the unit on. Again, when you're doing degree and leading coefficient, when we have this, right, in factored form, we can't just be like, oh, choose the highest power degrees 2, leading coefficients 1. When it's in factored form, we have to go through a little bit more of a process. So that's when we take each piece that has the highest power or the highest degree from each factor, right, x squared, x, and x, and we multiply those together, right? X squared times x is x to the 4th. That right there is that leading term that we need. Now we can look at that and be like, oh, the degree is 4, right? Because it has an exponent of 4, which is even. The leading coefficient, the number in front of x to the 4th, well, that's a 1. Leading coefficient is 1, and what we care about there is that's a positive 1. There's your degree and leading coefficient done, and what that tells us is exactly what happens on our end behaviors, right? The leading coefficient, because it's positive, tells us that the right side has to end by going up. Since the degree is even, degree being even means that the end behaviors go in the same direction, thus the left side also goes up. So with the degree and leading coefficient, we now know that on our graph, if we had to do it, we know that the right side and the left side go up. What the rest of this is going to do is tell us what happens in between our graph. Okay. Now let's look at x-intercepts with their multiplicity. So first, the x-intercepts come from each of these independent factors here. How we find the x-intercepts, there's a couple ways of doing it. First, you could think of it as the translations that we did back in Unit 1, where x plus 2 means we go left 2, x minus 7 means we go right 7. Or the other way you can do it is you can just set, just like we did solving by factoring, each individual factor equal to 0. So let me go here. For x-intercepts, we're just going to set each of these equal to 0. So x squared equals 0, x plus 2 equals 0, x minus 7 equals 0, and we can solve that. Now, those should usually be very straightforward. You don't necessarily have to set this up. If you're able to just see like x equals 7, x equals negative 2, then that's good, right? But the math behind it is we're subtracting 2 on that equation to get x equals negative 2. We're adding 7, we get x equals 7. And on this last one, x squared equals 0, that's telling us that x equals 0 because the square root of 0 is 0. But don't forget that is telling us an x-intercept. So those would be our x-intercepts. I'm going to put them in our answer, right? X equals 0, x equals negative 2, and x equals 7. Those are our x-intercepts. Now determining at those x-intercepts what the multiplicity is. Again, multiplicity is saying how many of that specific factor are there. So we look at the exponent, right? X squared, right, has that exponent of 2. That's telling us that it has a multiplicity of 2. There's 2 values of x there. This x plus 2, there's just one factor of x plus 2 that has a multiplicity of 1. And then for that x minus 7, that also has a multiplicity of 1. Because it's just 1x minus 7. It's when we have that exponent like squared, now it has a multiplicity of 2. If it was cubed, a multiplicity of 3. It's just saying how many times is that factor represented. But that gets our x-intercepts done. The last thing that we really need to graph is, other than the x-intercepts, we need the y-intercept, because the y-intercept makes our graph accurate. How we find that y-intercept is we're going to substitute, here, I'm going to say let x equal 0. That's how we find the y-intercept, because a y-intercept always has an x value of 0. That's what makes it a y-intercept. So what we're going to do is we're going to go into this equation up here, and everywhere you see an x, we're going to substitute in 0. Okay? So we're going to have y equals 0 squared times 0 plus 2 times 0 minus 7. Again, everywhere we see an x, we're plugging in 0. And we can simplify. Right? 0 squared is 0. 0 plus 2 is 2. 0 minus 7 is negative 7. And what's going to happen here is 0 times 2 is 0. 0 times negative 7 is 0. Whoops. Giving us a y-intercept of 0. Now when you write your y-intercepts, we need to make sure we write it as a coordinate point. The x that we plugged in was 0, the output we got was 0, so the y-intercept is 0, 0. Now anytime you have an x-intercept at 0, like this, our y-intercept will also be 0, 0. That's just a little shortcut you can use from here on out. If you ever have an x-intercept at 0, we have the y-intercept at 0, 0 as well. That finishes off the x-intercepts, the y-intercepts. So from that point, if we were graphing, we could go through and do the graph, but we don't have to. We're just finding the information here. These last two questions is just reminding you of vocabulary. So it's saying how many distinct x-intercepts are there, meaning how many different x-intercepts are there? There's 1, 2, 3. The second question, how many zeros are there? Remember, zeros are the same as x-intercepts, are the same as, what else do they call them there? Zeros, x-intercepts, it's skipping from my head right now. There's 3 of them though, because it's the same as x-intercepts. Roots, sometimes they'll call them roots as well. All of those mean the same thing, so there's 3 of those as well. It's just asking how many x-intercepts are there. But that finishes up that first problem for you. Alright, so here we go on one of these problems where we actually have to graph. Now that process that I just went through on number 2, or that you just went through on number 2, it's going to be the same process that we use here. It's just now we'll actually be able to put it on the graph. So let's go through those same steps. The first thing that we need to do is find the leading coefficient and the degree, right? That's what we need to find. That tells us the end behavior. How we find the leading coefficient and degree, especially when it's in factor form, we take that term with highest degree from each factor and we multiply them together. So we're going to go x times x times x is x cubed. And that tells us everything that we need for a leading coefficient and degree. The degree is 3, right? That's odd. And then there's a positive 1 in front of that, telling us that the leading coefficient is positive. From that, again, we know our end behaviors. Because the leading coefficient is positive, the right side has to go up. Because the degree is odd, the left side goes down. Odd is opposite, so they have to be going in the opposite direction. End behaviors are done. Now we know what happens on the outside of our graph, right? It should end up like something like this, right? The left side's down, the right side's up. To be accurate, now is when we find the x-intercepts, the y-intercept, and we can finish off our graph. So let's go into the x-intercepts. The x-intercepts, again, we take each of these independent factors here, and we're going to set them equal to 0. So I'm just going to put x-intercept. I'm going to go x minus 1 equals 0. X plus 3 equals 0, x minus 4 equals 0. And again, really, you don't need to necessarily do that. You can just look at this and be like, oh, x has to equal 1, negative 3, and positive 4 there, solving those equations, giving us our x-intercepts, right? So we can put those on our graph, right? We have an x-intercept at 1, at 1, 2, 3, 4, and then at negative 3 over here. Those are our x-intercepts. Now, for the x-intercepts, there's one more thing that we're supposed to look at. It's the multiplicity, right? That determines if they bounce or pass. So we look at the multiplicity of each of these. Again, it's just saying how many times is that specific x-intercept represented. There's only one factor of x minus 1, multiplicity of 1. Same thing for the x plus 3 and x minus 4, there's only one factor. What changes the multiplicity is when we have exponents. Like if it was x minus 4 cubed, now it has a multiplicity of 3. But they all just are being represented once, multiplicity of 1. And if you remember, odd multiplicities mean that for each of these, we're going to be passing through. Okay, so let's add that to our x-intercepts at all of them. We're passing through. Again, the difference between passing through and bouncing, we'll get to that when we graph. Just make sure you understand that the difference is when you get to a point, if you're passing through it, you go through the x-intercept up into the next like half of the graph. If it was a bounce, you would get to that point, and instead of going up, you would get to the point and bounce down. That's what the bounce is. It's not like looking at the curves in the graph. X-intercepts are done. To finish off this graph, the last thing we need to do is find the y-intercept, and you have to make sure you find the y-intercept. Do not skip this step. To find the y-intercept, we let x equal 0, or we set x equal to 0. Again, what we do is we substitute x in for, or 0 in for x in all of these equations here, and we can simplify. So we're going to go y equals 0 minus 1, 0 plus 3, 0 minus 4, and we can simplify. 0 minus 1 is negative 1, 0 plus 3 is 3, 0 minus 4 is negative 4. We're multiplying. Negative 1 times 3 is negative 3. Negative 3 times negative 4 is positive 12. So we get y equals 12. Make sure you write this as a coordinate point. The x is 0, the y is 12. That's your y-intercept. And we can add that onto our graph. Now you don't have to put 12 dashes, just mark your y-intercept. 0, 12 would be up top, and label it 0, 12. Now we have the y-intercept in our graph, and now we can finish our graph. Keep in mind the y-intercept is going to help us determine if we make any mistakes or not while we do our graph. So we start with the end behavior. Let's start with the left side. The left side goes down, which means that this farthest to the left side should go down. Now we get to this point here, and we're told to pass through. Again, passing through means you go through the x-axis. If it was not a pass through, it was a bounce, then instead of us going up like that, we would shoot down in that direction. That's a bounce. But we're passing through, so we go up through the x-axis. We come up, make sure you go through the y-intercept. That's why we put it there. We come down to this next x-intercept. Again, we're passing through, so we're actually going to go through that point. We're going to come down into this lower two quadrants, circle back. We get to this last x-intercept here, and again, we're passing through, so that means we go through that point up into the upper two quadrants again, leaving us there, which is good because like our right end behavior should be going up, so it checks out. That's our graph done there. All right, so you just have to make sure you're able to go through those steps, find the x-intercepts, find the y-intercept, and the end behavior, and if it all matches up, then we're good. If we had instead like had to bounce here and our y-intercept is up at 0, 12, then we could know there's something wrong with our graph, or maybe back with some of our work. So just make sure you're being careful. I'm going to do a couple more here just to make sure that you have some more examples to look at. All right, so here we go on number 8 from your homework. Again, I want to give you some more examples here to follow if you need some more help. We're graphing, we're going through the same steps. You need to find the end behaviors, x-intercepts, y-intercepts, and we can graph. Now, let's start with the end behaviors. Again, end behaviors mean we need to find the degree and the leading coefficient. Whoops. How we find that degree and leading coefficient when it's in this factored form is we take that leading term there, that term with the highest degree, and we need to multiply them together. Now, what we have to be careful of here is for this x plus 2, it is just an x. But for this second one, x minus 3 squared, we have to take that exponent of 2 and give it to the x as well. So we have x times x squared times x. Now the biggest thing that's usually forgotten is this negative 1/9 out in front. That comes along as well. So we go times a negative 1/9 at the front, giving us negative 1/9. We have 4 x's, x to the 4th. And that right there is our leading term, which is going to give us our degree and leading coefficient. You look at it, the exponent is 4, so the degree is 4. The leading coefficient is that negative 1/9, which is a negative number. Sorry, the degree is even, which is what we want, right? Because now, if the leading coefficient is negative, that tells us that the right side has to go down. And since the degree is even, that means that the left side goes in the same direction, which means it also goes down. We know our end behaviors. It should end up looking something like that where the right and left side both go down. Okay, now we can move on to the next step, right? The next step is finding the x-intercepts. Again, to find the x-intercepts, what we're going to do is set each of these independent factors here equal to 0. So x plus 2 equals 0, x minus 3 equals 0, x minus 1 equals 0. You do not have to set x minus 3 squared equal to 0. The exponent's not going to change the specific x-intercept. It's just going to change something about our multiplicity. We solve those, we should get x equals negative 2, x equals positive 3, x equals positive 1. Those are our x-intercepts. We can add those onto our graph, negative 2, positive 3, and positive 1. And the last thing we have to do there with the x-intercepts is figure out what's the multiplicity, because that determines if you pass through the x-axis or you bounce off of it. So we look at the factor of x plus 2 that has a multiplicity of 1 because there's just one factor of it, so that's passing through. Look at this factor of x minus 3. That has that exponent of 2, right? Telling us that it has two different factors of x minus 3. It's a multiplicity of 2, telling us instead of passing through there, we're going to bounce when we get to 3. And x minus 1, there's just one factor there telling us it's a multiplicity of 1, telling us it's going to be a pass-through. Okay, now what I'm going to do is just label those on here, right? At negative 2, we're passing through. At positive 1, we're passing through. And at positive 3 there, we're bouncing. And we could almost finish our graph here. The last thing you have to do, and it's commonly forgotten, is you have to find the y-intercept. Again, to find the y-intercept, you're going to set x equal to 0 and simplify. So we're going to go y equals negative 1 over 9, 0 plus 2, 0 minus 3 squared, 0 minus 1. And we simplify. We get negative 1 over 9, 0 plus 2 is 2, 0 minus 3 is negative 3, negative 3 squared is positive 9, and then 0 minus 1 is negative 1. To finish off, we multiply here. Right now, it might be easier to do the whole numbers first, and we'll deal with the fraction at the end. 2 times 9 is 18. 18 times negative 1 is negative 18. Now we have this, negative 18 times negative 1 over 9. The negatives cancel out, so this is going to be positive. And this is really just doing 18 divided by 9, which is 2. Telling us that y equals 2, giving us the y-intercept of 0, 2. Okay, and we can add that onto our graph. 0, 2 would be right there. And now we should be able to go through and do our graph. So again, let's start with the end behavior. The left side should be going down, so that means at this farthest left point here, we should be going down. We get to that point, and again, we pass through the x-axis, meaning we go up into those upper two quadrants. We get to that y-intercept. Make sure you go through it. Now we come back down to this next x-intercept at 1. Again, we're passing through the x-axis, which means we go down into these bottom two quadrants. Circle back up to that last x-intercept there, and this is a bounce. Bouncing means when we get to this x-intercept, instead of us going up like that, bouncing off of the x-axis means we get to that point and we shoot right back down into that bottom quadrant again, giving us the right end behavior going down, which is exactly what we need there, and that finishes off our graph. You have to make sure you find all of these components, especially the y-intercept. It's the most commonly forgotten thing. But hopefully that helps you out there. I'm going to do one more of these examples from your homework. All right, here we go. Here's the last one I'm going to do with y'all from worksheet 2. We're graphing, and we need three things. We need the end behaviors, the x-intercepts, the y-intercepts. Let's start right there with end behaviors. We need the degree and the leading coefficient. Again, how we find the degree and leading coefficient. When it's in factored form is you're going to take each independent term of highest degree from each factor and multiply them together. So we're going to take that x, this x, this negative x, and this x at the end. And oh, don't forget that 2 out in front, that does count as a factor. We're going to multiply those all together. So we're going to go 2 times x times negative x times x, which gives us negative 2x to the fourth. That's our leading term, and that's where we can find all of our information from, right? The degree, again, is that exponent that you see, that's 4, which is even. The leading coefficient, which is that negative 2, that's negative, which tells us everything we need, right? The leading coefficient tells us what happens on the right side. Since it's negative, the right side has to go down. The left side, then, we can look at the degree. Since it's even, that means our end behaviors go in the same direction. If the right side goes down, the left side also has to go down. End behaviors are done. Now we're going to move on to the x-intercepts. Right, now to find the x-intercepts, we set each independent factor here equal to 0. Right, when we go x-intercepts, we're going to go 2 equals 0, x plus 4 equals 0, x plus 2 equals 0, etc., etc. Again, you don't have to do this if you're able to just see, like, this x-intercept's at negative 4, this one's at negative 2, that's fine, right? You don't have to sit there and put all of that work. I'm just showing you where we're getting that from. Now, the 2 I didn't do, it's because they're unique. This right here, you do set it up, but that doesn't give you any value of x. That doesn't tell you anything. And this one, to solve that for x, just add x to the other side, telling us we have an x-intercept at x equals 2. So we end up having these 4 distinct x-intercepts. The last thing we need for x-intercepts is to determine what is their multiplicity. Right? Multiplicity meaning how many times is that x-intercept represented. So what you do is you look at the factors that gave us that x-intercept, that x plus 4, right? There's only one x plus 4 here, so it has a multiplicity of 1. Odd multiplicity means we pass through. Right, now let's do the same for the next one, x plus 2. Again, I only see one x plus 2. Again, multiplicity of 1, odd number passes through. Same thing for the 2 minus x and the x minus 1. They're both represented once. That's an odd number. That means that they both pass through. Now, just bear in mind, it's not always a pass through. Sometimes it is a balance when you have an even multiplicity. What that could look like is maybe instead of x minus 1, they put x minus 1 squared, meaning that there's 2 factors of x minus 1. That gives you a multiplicity of 2. Another way you can do that, or it could be represented, is like this. What if there's another x minus 1 added on to the end? Now again, there's 2 factors of x minus 1, giving it a multiplicity of 2. So just keep in mind, there do end up being multiplicities of 2, okay? Or 4, or etc., okay? But from that, we can graph these. Let's put those x-intercepts on there. Negative 4, 1, 2, 3. Negative 4 here, it's passing through. We have one at negative 2 that's passing through. We have an x-intercept at positive 2 passing through, and the last one is at 1, which is passing through, all nice and tight together, which is going to make this graph excitingly fun to graph. It's going to be hard because they're real close. I meant like just drawing it, not like the graph itself. The last thing and the most commonly forgotten is finding the y-intercept. You need to make sure you find it. To find the y-intercept, again, what we do is we're going to let x equal 0 and solve this equation up at the top, right? So we're going to plug in 0 everywhere you see an x. So we get y equals 2 times 0 plus 4, 0 plus 2, 2 minus 0, and then 0 minus 1. And we can simplify. Still a 2, 0 plus 4 is 4, 0 plus 2 is 2, 2 minus 0 is 2, 0 minus 1 is negative 1. From here, again, we're multiplying. 2 times 4 is 8, times 2 is 16, times 2 is 32. It's a negative 32 because it gets multiplied by a negative 1 at the end. If you need to use a calculator right there, use a calculator, okay? But after we get that negative 32, that gives us the y-intercept, which is 0, negative 32. Make sure you write that as a coordinate point, and we can place that on our graph. So make sure you label it. Now we can officially finish our graph. Again, start by using those end behaviors. and we can go through it. So the left side goes down, right? Left side goes down. So this farthest left point, we should end up going down. You get to the x-axis, again, we're passing through the x-axis here. So instead of shooting down like that, which would be a bounce, you go up through the x-axis, come back to the next x-intercept. Again, we're passing through, so we're going to go right back down into that bottom 2 quadrants. Make sure you go down through your y-intercept. Come back to that x-intercept at 1. Again, we are passing through, so you're going to go up into the upper 2 quadrants. Make sure you come back to that last x-intercept there at 2. We pass through it, again going down now into the bottom 2 quadrants, giving us a shape that looks somewhat like an M. I kind of deviated at the end, but what we need to see is that right end behavior is going down. Checks out, right? Our right end behavior does need to be going down. That finishes off number 9 for us. Again, you're finding those 3 pieces on all of these examples where you need to find the degree leading coefficient for the end behaviors, the x-intercepts, determining if they bounce or pass through by the multiplicity, and then the last thing is the y-intercept to make sure you have that exact graph. After that, you're finished up with those graphing problems. Again, let me know if you have any questions.